Hello, environmental scientists. We are back, and today what I want to discuss is what are the kinds of things that need to be done to slow global warming and climate change. Let's get started. The first thing I want to do is look at who is to blame, because we haven't talked about that, so this is just a short digression into that. And if we look at the figures from 2009, we see that the number one emitter was China, the number two the United States, then the European Union, etc. And if we look at the change by 2015, and unfortunately these statistics came from a slightly different source, we see that China and the United States are 1 and 2, but the European Union isn't taken as a block and it's broken up. And we see India's in third, with Russia in fourth, Japan, and then Germany. But that is a little misleading because we also want to look at cumulative emissions. And when we look at cumulative emissions, because a lot of that carbon dioxide is still in the atmosphere, so cumulative emissions are important, we see that the United States has been by far the largest emitter, with China quickly catching up and Germany far behind. I also want to talk about why dealing with climate disruption is so difficult. Even if there weren't any trolls in the mix, and there are trolls in the mix, as I will point out to you in the coming days. But here's why the problem is so intractable. It's global, and therefore it requires international cooperation. It is a long-term political problem, and people most affected are in the future, although with the increased intensity of storm, increased droughtiness, increased rainfall, increased sea level, we're seeing that the problem is more and more here today. We've already talked about the inherent cognitive bias, which makes it difficult for people to deal very effectively with long-term threats. And to me, that's a reason why we need leadership that looks out for the common good and the rest of the planet, because that tyranny of small decisions just takes over. And we need a governmental structure that looks out for all of humanity and the rest of the inhabitants of planet Earth. In addition, the harmful and the beneficial impacts are unevenly spread. The earliest predictions are that tropical countries are likely to be the most adversely affected, and these are many developing nations. And we're also going to ask these nations to curtail economic growth, and we're going to ask them to do that because of actions of the already rich countries, and that just seems hypocritical and like it wouldn't be effective anyway. As a result, we've seen how the UN deals with the fact that environmental sustainability has to include economic development for the poorer countries as well. Many of the proposed actions disrupt economies and lifestyles that people have grown used to, so this is another difficult problem. I also need to talk about politicization of the issue, because it makes the solution less likely. And this is a case I'm going to be making over the next few days too, especially when we see the film. From 2006 to 2010, precisely a period where we should have had a tremendous amount of action taken in this country, just after Al Gore's film, An Inconvenient Truth, came out, when there was a lot of groundswell to deal with climate change. The issue became ultra-politicized, as it had been since the 1980s, and the number of Americans who believed that climate change and global warming was exaggerated rose from 30% to 48%. And that was orchestrated. And why? It's largely been corporate money, particularly from the fossil fuel industry. We will also look at how they played on the public's lack of knowledge about how science works, the idea that scientific facts are never certain, but they are as good as we can get. And they also played upon the public's lack of knowledge about the difference between weather and climate. It's much more difficult to build a national and from a national to a global consensus when there are powerful interests that have an economic interest in denying facts and spend a lot of money to deny those facts and muddy the waters. And yet that's exactly what's been done. And we're going to see how that's been done as we move forward. The good news is that recent polls, particularly since Donald Trump has been in office, show that Americans have become increasingly convinced that climate change is real and that the American government is not doing enough to deal with it. It's going to be an interesting road forward with those poll numbers coming in. It seems to me there are three basic options at this point. One, we can drastically reduce the quantity of greenhouse gas emissions, make a carbon plan, and start to live to it. Two, We can just deal with the symptoms of climate change. We can devise strategies to reduce the harmful effects of global warming and maintain our emissions at the same level, try not to increase them. Or 3, we can do nothing, just maintain the status quo and just see what happens. One of the fears that is often discussed is reducing greenhouse gases is going to severely hurt our economy. And is this true? Can there be an economic boom? And many people say yes, there can, because conversion to a more sustainable economy will be an economic boon. It will create a huge amount of jobs as infrastructure has to be changed, as new technologies are invented, which will allow all sorts of entrepreneurship and new inventors to come out of the woodwork and come up with real solutions to real problems. But this, of course, is opposed by money interests, and they get a lot of airtime. On the next slide, I have the bare bones of a carbon plan, and here it is. This is from the textbook, and if you look at this, you can see that this bare bones plan is really about technological sustainability, not about really changing the way we live. But here are some of the ideas. Cut fossil fuel use, improve energy efficiency, shift to renewable energy resources, put a price on greenhouse gas emissions, remove CO2 from smokestacks and vehicle emissions, sequester CO2 deep underground, repair leaky natural gas pipelines, use animal feed that reduces CH4 emissions from cows, etc., etc. All great ideas. I don't want to poo-poo them, but they're not asking us to do anything that will really drastically change our life. Our life will change slowly and incrementally, and we'll probably get used to it. So the major prevention strategies that have been proposed are predicted to reduce emissions by 57 to 83%. Okay, that's a lot. These would be things like improving energy efficiency of fossil fuel using technology, increasing gas mileage in cars, having less power in our cars and more efficient cars that can go a longer distance on a tank of gas. Increased use of low carbon renewable energy resources, and we're going to be studying them in about 2 to 3 weeks. You will be starting to learn about those. Stop cutting down forests, particularly tropical forests. Reforest the planet. Shift to sustainable and climate-friendly agriculture. In other words, let's not make agriculture energy intensive, but let's turn it into a net energy source, as opposed to now where in the United States, something like for every unit of energy we get out of agriculture, we put in 5 units of energy in fossil fuels. So the first part of a carbon plan would be to prevent and reduce greenhouse gas emissions, and those are some of the ideas about how to go about that. The second part of such a plan would be to start collecting greenhouse gas emissions and putting them somewhere. And those ideas consist of things as follows. Plant a lot of trees. How many? I personally don't know, but I know there have been studies that show how many trees need to be planted, how many hectares of forest need to be planted in order to capture a certain amount of carbon. Another idea would be to restore wetlands. Wetlands especially have been drained for farming, and to restore these, we could put in an incentive program where farmers would restore their wetlands. This would have so many benefits, aside from an energy benefit. It would create habitat, it would recharge groundwater aquifers, it would reduce runoff into rivers. But in addition, wetlands are carbon sinks because wet organic matter doesn't tend to decay very well, and so it tends to accumulate. We could start restoring habitats with fast-growing perennials that suck up a lot of carbon. We could restore forests, and several studies believe that ecosystem restoration would be a very effective way. And later on in the year, we're going to see some films about ecosystem restoration. Really fascinating topic. Here's another one, that technology that an entrepreneur came up with, which is biochar. It's a type of charcoal that is made from biomass that would otherwise decompose, and when placed in the soil, it acts as a fertilizer, but it also sequesters carbon. So it would improve fertility, so it could be used in agricultural land, but it also pulls carbon dioxide into it. We could seed oceans with iron to stimulate growth of phytoplankton. This is an interesting idea, but I wonder about the systemic repercussions. Can you only do one thing? Would that be its only effect? And then finally, we have this technology called carbon capture and storage. This idea is capture the carbon emissions from coal-burning plants. To me, this doesn't seem like it's likely to be successful, but maybe it would be. Maybe it would increase the price of using fossil fuels so much that the alternatives would be developed, and therefore it would be a successful strategy. What seems to make the most sense to me is figuring out ways to reduce CO2 production in the first place. Carbon capture and storage. I wanted to talk about this. This is being pioneered in a number of places, particularly in Germany. Basically, the idea is you capture the carbon dioxide as it is rising in smokestacks, and you convert it into a mineral and store it somewhere underground. There's problems with this approach. It requires a large energy input to work, which itself creates CO2 emissions. It promotes the continued use of coal, which is the world's dirtiest fuel, and take out the CO2, but perhaps not take out the sulfur or the mercury, which are big problems. And the stored CO2 would have to remain sealed forever. It couldn't leak. If it slowly started to leak back into the atmosphere, we would have a big problem. Here's a mock-up of what it would look like. You've got a process where a coal-burning plant is capturing carbon dioxide, turning it into a carbonate mineral, and then as a slurry pushing that into depleted oil and gas fields well under the earth. And hopefully it will be out of sight and never come back. It will certainly be out of mind, so it may not be well monitored into the future. This kind of technology has led to geoengineering schemes to slow climate change. And when I say geoengineering, I mean literally engineering the entire globe to slow climate change. Let's look at some of the things that have been proposed on a global scale. One is to inject sulfate particles into the stratosphere, that second layer of atmosphere, and they act like little mirrors and reflect sunlight. Would it have a cooling effect? Nobody really knows, but it's a possibility. It should, in theory, work. Would it accelerate ozone depletion? Would it have any effect on ozone? That's a question that people have had. And would it create too much acid deposition? Because sulfate particles will turn in the atmosphere into sulfuric acid, and that would create acid rain or acid deposition all over the globe, which we will talk about later in the year. Another idea is to put giant mirrors into orbit around the Earth and simply reflect light back to Earth. Another idea is to use large pipes to bring nutrients from the bottom of the ocean up to the top to promote algal growth in the ocean and therefore carbon fixation. Some portion of those carbon skeletons would fall to the bottom of the ocean and become minerals. So we would just enhance this process by stirring up the ocean. Do these seem a little crazy to you? They've been seriously proposed by some people as solutions. They seem like in a global system that has many unseen compartments that it would be very difficult to accomplish these goals. But I think there's a fatal flaw to all geoengineering schemes. They don't address the continued buildup of CO2 in the atmosphere. Some levels would likely skyrocket. Let's say sulfate particles kept the Earth cool. Everybody would burn more and more fossil fuels, and the CO2 would build up. They'd be costly, and there's no guarantee they work. But let's say they do work. They require a huge amount of energy, more CO2 into the atmosphere. But if they work and then they fail, warming would occur at a very fast rate, and also probably an unstoppable rate at that point. And that, to me, seems a little bit scary. A more rational approach might be to use governmental structures to actually move us in a direction we want to move, which is away from fossil fuels, away from putting all greenhouse gases into the atmosphere, and figuring out new plans as we go. So one would be to regulate CO2 and methane, CH4, as pollutants. And this, of course, is opposed by corporate interests, but it might actually be a great idea. We could do this by putting a carbon tax on fossil fuels. That the idea is that polluters pay. You use the fuel, you pay. This would, of course, mean a big increase in gasoline prices. They would become more in line with European prices. Second is a cap and trade approach, which would set permissible emissions for every company and then allot these to companies. So companies would have the right to produce a certain amount of CO2. And if they went above that, they'd have to pay for it. And if they didn't, if they went below it, they could sell their right to other companies on an open market. Or we could have the government put the caps on and sell the rights and collect the fines, and we could have the public get the profits from the sale. So those are called cap and trade problems. We could subsidize energy efficient technology and stop subsidizing fossil fuel technologies that emit greenhouse gases, because there's a huge amount of that going on. And we could work on technology transfer where we help defer the costs of transferring green technologies to developing nations. So there are a lot of potentially very successful ways we could use government to implement policies that would reduce carbon dioxide emissions. So that will wrap up today's talk. Tomorrow we will take a slightly deeper look at how these government policies could work, as well as international agreements and how far they've gotten, as well as what individual countries and individual states have done to address climate change. And then we'll wrap up this unit on climate change. But until then, study hard.